Okay, so this is a quadratic that is in what's called standard form. So standard form here just means that squared plus bx plus c. In this case, a is equal to -1, b is equal to 8, and c is equal to -12. So when you have a quadratic that is in this form, to find the vertex, the x value of the vertex is equal to -b over 2a. So let's go ahead and find that. So -b in this case is -8 all over 2 times -1. So the vertex here is going to be -8 divided by -2 or 4. Now, how do you find the y value of the vertex? The same way that you would for any equation. You want to go ahead and plug x is equal to 4 into the original function. So watch your signs. That becomes -4 squared plus 8 times 4 minus 12. And all of that also equals 4. So let's go ahead and put that vertex in. That is 4, 4, which is going to be right here. Now, with this, because a is negative, because this first term is negative, we know this parabola will be going down. So we know this vertex is going to be the maximum. It will also have an axis of symmetry at x is equal to whatever that x value of that vertex is. So that gives us an axis of symmetry right there. The next thing I'm going to look for here are my x-intercepts and my y-intercepts. So to find your x-intercepts with this question, you just take your original function and set it equal to 0. So that gives us -x squared plus 8x minus 12 is equal to 0. Now to find this, I have to go through and factor. So I'm going to first factor out a -1 to make it just a little bit easier to deal with, and that will give me x squared minus 8x plus 12 is equal to 0. And then I go through and factor that. I know that if I'm looking at these last factors of 12, I need some combination that is going to equal a -8 with both of the signs being negative. So that's going to need to be a 6 and a 2, all equal to 0. So solving this, I get the fact that x is equal to 6 and x is equal to 2 will be my two zeros. To write them as a point, it would be 6, 0 and 2, 0. And I'm going to go back up here and then graph those. Okay, I also will always ask you what the y-intercept is. So to find the y-intercept, just go back to the original equation, which is, again, your f of x is equal to -x squared plus 8x minus 12, and let x be 0. When it's in this form, it will always equal whatever the coefficient is, and that's because wherever you have an x, it becomes 0. This only is true when it is in standard form. So now I'll come over here and graph that. That's a little bit off the graph that I have here, but I'll just go ahead and that's going to be -11 and -12, so it'll put it down here. So let's go back up and finish graphing this and talk about the domain and range of this. So let's go ahead and graph this. All right, so there's the graph. The domain of the parabola is going to be from -infinity to +infinity because all values you can use for x. The range of the parabola. Now this parabola is going down, so again, I'm going to go back and use this same idea of whenever you have this, look at where you shade from the graph over to the y-axis. That's what matters. Now, I am starting here at 4 and going down. So that gives me a range from 4, and 4 is included, going down to negative infinity. But don't write it this way. Always go from negative infinity up to 4. Remember, when you're doing range or domain, you always have to start on the left-hand side as the smallest value. So be careful. Even though the graph does go from 4 going down, when you write the range in interval notation, it must be the smallest value going first. So we have our maximum here, which is at the vertex, which is 4, 4. We have our axis of symmetry, which is x is equal to 4. Our domain and our range are X-intercepts, and our Y-intercept is down here. Do be aware that sometimes when you're finding your X-intercepts, you may need to use the quadratic equation. For this section, you will want to go back and review how to factor and how to solve the quadratic equations if it's something you need additional practice with.